All right. Well, so just another reminder, Hackathon's this Saturday, 8 a.m. in this zone in here somewhere. Usually it's down at 118 where they have the food at breakfast time. You should have been in contact with your team leads by now. So I don't know if they've emailed you or set up a Slack message or whatever, but if you're not in contact with your team lead, reach out to them. The teams are all listed on Slack. Also, the project thingy, whatever, is on Slack, so you kind of know what you're working on. So as a team, you can start brainstorming. V, you're late. You missed a quiz.
We do?
You missed it.
That's sad.
10 minutes ago. Killing me. All right, so we're going to do more merge sort stuff today.
You don't have homework, right?
Huh?
Oh, no, lots of homework.
No, we weren't going to have homework, but then when all these people didn't show up, now we have homework.
What? I'm just trying to make you better in recursion.
Can we have a class for that class?
Huh?
Wait.
We're going to sort of do something. So here we're gonna spin a Christian worldview into this, as well as building data sets, and then bringing those data sets into objects, and then merge sorting those objects. Okay, because sometimes you're going to end up writing a computer program, and you want to. So what we're going to do in here is we're going to create objects for books, and a book is going to have a name. It's going to have a number of chapters. Okay, and what we're going to use as our source is we're going to use Bible books. Well, so we have a couple of options. We can go in and we can, open up the Bible and type in, Genesis, Exodus, Leviticus. We can just keep going through and typing them by hand, and then have to look at each one and see how many chapters are in that. All sorts of that stuff. We could even maybe go down to verses if we can get that data. But let's just assume that's the problem we're trying to solve. Okay, we're trying to solve collecting into our program a object-oriented way of holding Bible information. All right, so now we can look at automated ways that we can go and try to get this information. All right, so we're probably going to start by doing some Google searches or whatever, just looking to see if somebody out there has a list of all the Bible books. Start off with just that, and then we can go from the next step. So let's just see, Bible book list. All right, so this one's going to have some stuff. Oh, yeah. Because remember we were talking about how many chapters are in it? Okay. So this is really the data we want, right? So I mentioned we were going to have the name of the book as well as number of chapters. All right, so I'm going to highlight all this data. All right, now, if I just go, and let's, just for the sake of, let's see. I just want to do this for a kind of a one-day thing, so let's do this in Eclipse. Because we're not going to build an interface and stuff like that. I just want to have some stuff. That sound okay?
Okay.
No, you're late. Can't ask questions. And actually, you were here for everything. All right, so I'm starting an Eclipse project. I'm going to go to File, New, Java Project, and we're going to call this guy Bible Sorter, something like that. All right. And then inside my source directory here, I'm going to create a new class. And just like old school days, we'll call this guy driver. And I'll have it go ahead and throw my main method in there. All right, we can read that. All right, and I'll go ahead and run this real quick, just to make sure we have a functioning program. And there's your hello world. Was it Austin or Luke that said that? Yeah, so there's your hello world completed. All right, so now we have this data that we've copied. I'm going to go ahead and just paste that data in here. All right, so now this looks a little funky, right? We'd have to go through and maybe put some double quotes around this and all sorts of stuff like that. So we'd have to spend some time manipulating this data to get the information that we want out of it. Now, could we do that? Would that be the end of the world? We've already saved ourselves a bunch of time having to type all this stuff in, right? But maybe that's not the best starting point for us. So what I'm going to do, so what would be your suggestion? I have all this data. What would be a nice format to have this data in that would allow us to easily work with it inside of our program, given the tools that we have in our toolbox?
JSON file.
Okay. Say dictionary. Well, we ultimately want to get it into like an array or some objects or something like that, but I need to be able to read this into my program and then split it out into different things. So in terms of me getting data that looks like that, now reformat it in such a way that it looks good for my program. What are some tools I can use? This goes back to 150. This goes back to actually first week of 200 when I say that computer programming, computer science is the other side of the IT coin, right? 75% of what we do is creating new stuff. 25% of what we do is using things that have already been created. Okay? As programmers, have we forgotten that we have other applications that are on our computers? Have we forgotten that there are things out there that might be able to take this data and more conveniently reformat it for us so that we can now get it into our program and work with it a little bit easier? What would be an ideal format for this stuff to be in? Maybe a string, yeah. So maybe you have like a double quote there, maybe a comma here, and then all this stuff is under double quotes. And commas in between each one, something like that. Yeah, so then we can kind of split on commas. We can break it apart on commas, or we can create a string tokenizer and split it on commas. So if we had this thing as a comma delimited list, that would be helpful. What do you think?
Use like an external file, like CSV or something.
Okay, so how would we create a CSV file?
You could just make a text file separated by commas and then change the
Okay, I'd still have to go in and type the commas in there though, right?
presumably.
Okay, now there's a chance that we're going to have to do some typing anyways. Okay, but we're trying to automate things as the best we can. So what kind of tool do we have on our computers that might let us export to a CSV file? So a spreadsheet, right? All right, so let's get rid of this stuff. Now, do I have Excel on my laptop? I do. Otherwise, I was going to use numbers. All right, so I'll paste this stuff in there initially. All right, and I think, is that putting it all into, yep, so that put all of that into column A. All right, so if I even just stop right there, I can now do, let's see, where's file on this guy? Is it over here? I want to export. Where's my export?
It's up in the top bar. Like the very top.
Oh. I'm on a Mac. These things separate on Macs. They have for years. It's looking exactly like a normal Mac application is looking, but I was using a Windows machine earlier, so I'm in Windows machine mode, looking at this top bar and wondering where all are my fields. All right. So we'll go to File. There's probably an export in here. Do we have to do it maybe as a save as? Let's look at save as and see if it lets us choose a CSV as our file format. Yeah, so here's a comma delimited list. So we'll call this guy Bible books. And I'm going to store it into downloads just so I don't have it making a mess someplace else. So I'll hit save. So now I have something called Bible books inside of my downloads. Okay, now if I go and I double click on that, it's going to open back up in Excel, right? Excel is kind of probably the default application for opening a CSV file, a comma separated values file. But what if I go into text edit and I go to my downloads and I go to my Bible book CSV, did it not actually put commas in there? Or is it trying to show it to me in a, here, let me test something else here. Well, Adam would actually probably be pretty good. I was going to do something more old school, but so here I'm going to do. We'll use the command line. I'm going to say cat, dog. So we're going to say cat. Yeah, there's no commas in there. I didn't put it in a comma separated file. It's called concatenate. It outputs the contents of a file. All right, so this did not do what I wanted it to do. So there's got to be an export thing. So saving this as a CSV file didn't. Here, let's just Google it real quick. Excel export CSV. What's the with quotes thing?
Oh, with commas.
Well, okay, I said comma separate. I want to actually see the commas. Yeah, I want that.
Wait, which version? Did you save the CSV? Well,
Possibly. Let's go try it again.
Do you want the commas
I want the commas
after what?
Yeah.
after each. So I want it
Item.
after each item.
go to
But it should automatically do that since
Doesn't that just copy the end line? So like they don't need it. They just need a comma after each value in a line, but after the next line, it doesn't need a comma.
Well, yeah, but I didn't get any commas. There was no commas in here.
try going to
So we'd have a comma here, and a comma here, and a comma here. This is comma delimited. Let's go to options. No, nothing there.
file format and change it to CSV. Because I have two different types of CSV.
Yeah, here's just comma separated values. Let's try that one. Well, that didn't give us commas either. Wonder why that doesn't show us the commas.
Well, I'm pretty sure a CSV file only has commas. Because like if you see there, it only has commas at the end of each item in the row. It doesn't have it at the end of the row itself.
Yeah, I see what you're saying.
So it counts the end line.
Okay, well, that's okay. We can still work with this. So we have effectively just a text file that has all this crap in it now, right? All right, so we want to be able to get to this this text file. I need to give it the full path. So let's just do some file IO stuff. We'll read it in from a file since we have this stuff stored now in a interesting format. I wonder why there's question marks with Exodus, Genesis. Was it in here? That's just how it copied. That's just how it copied. So with that in mind, then I'm just going to open up. Oh, did I not have it open? I'm going to open up text edit. I'll just create a new document. So this is equivalent to Notepad on your Windows machines. I'll just paste all this stuff in here. I'm going to change it to plain text. All right, I don't really want the dots before it, so actually let me copy everything from Excel here instead. I want to have the data as clean as possible. All right, so now we have these guys, and at the end of each line is a carriage return, right? So we can now save this file, read the file into our Java program and read each line of the file in. Make sense?
Do you want to delete, like Ezra and Daniel have letters at the end?
Yeah. There's an A
It's
and
like
D.
10 chapters, and then there's A.
Yeah. Well, we can. That wouldn't take very long to do. That would save us from having to do some editing in code, searching for those parts. Because reality is, even since each one of these has a opening parenthesis as its splitting point, we can split on opening parentheses per line, and these guys would get 3 parts instead of 2 parts, and I would just use the first 2. So if we want to make say, I don't want to touch any of my text, if we're trying to have that goal, where I've grabbed this off the internet, I've thrown it into a text file, I've gotten it, first I threw it into Excel, and Excel took the bullet points off of it. Then I copied from Excel and pasted it into a text editor, and then made it plain text. So that took all the link stuff off of it. So now it's just text. And each of these has a carriage return at the end of the line. If I come back here and I backspace on this, it puts it there. Press enter, it puts it back here. So there's a carriage return at the end of each line. So if I can go and read this file in, that would be beneficial to me. I can bring this data now into my program, right? And then I can manipulate the data from there rather than us having to type all this stuff in. So I'll go ahead and save this, and I'll save it in my downloads, and we'll call it just Bible Books. It's going to save it just as a text file. What's it going to call it? Yeah, just BibleBooks.txt. It's actually probably not even .txt is my guess. Yeah, it is BibleBooks.txt. All right, and this is the full path to it. We might need that, so I'm going to copy that full path where that file lives. Now we're going to go do some file I/O in Java. So we can do this with our scanner. We can also do it with like a buffered reader, but we're going to need a file reader first. So let me just go to our documentation here. I like the frames version of this, don't I? Yeah, that's the one I like. Okay, so I want to be in java.io. That's where the is it in java.base.io? Yeah. So java.io should have my file class things. So here's a file input stream. Remember, we've used scanner before, and scanners require input streams. So if I look at my file input stream, one of the ways I can open a file is with the string. So this is opening a connection to an actual file, by the path name in the file system. So I'm going to give it that full path that I just read. So we're going to come in here to Eclipse. I'm going to say I want a file input stream fizz is equal to new file input stream, and that's the full path to the file that I want. Okay, now notice it doesn't know about file input stream. I need to import it from java.io, so I'll go ahead and do that. So now I've imported java.io.file input stream here. Now we're also going to need, this guy's probably a TryCatch, right? Yep. So this can possibly throw a file not found exception. I've given it the full path to something I think will be found. So I'll just throw all this inside of a TryCatch. So I'll say try to do this crap. Catch an exception if one happens. And we'll just tag our exception onto the end of it so we can see what the error message looks like. But hopefully we find the file since I gave it the full path. But sometimes Eclipse can be a little funky with paths, so we might need to mess with that a little bit. If you're on a Windows machine, this would be like C:\/ blah, 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 blah. All right, and then I'm going to go ahead and create a scanner. Using my file input stream. And scanner comes from java.util. Yeah, java.util. So import scanner. All right, then we could say while input dot has next. So while there's more, here it has next line. I like that one. So while there's more lines inside my input, we'll go ahead and say system.out.println input.next line. And that'll read in the line. So hopefully the output of this program right now is all of our Bible books that were in that file brought into our program, spit out to the console. That's what we're hoping we get as an output here. And let's see what dies. So there's all of our Bible books. All right, so now what we can do is we can go ahead and load those guys into something, right? We can do something with those. Now, I wonder, does input tell me how many lines there are? I doubt it. So here, we're going to do it this way. So I need to store a collection of strings, and I don't necessarily know how many strings there are. What's the right tool for the job?
While loop.
How about I just ask the question again, and maybe we get a more sane answer. I have a collection of things here that are already coming in, right? I got a while loop here, Blaine. You got this guy? Yeah, we're good. We got this. Okay, so each one of these is a string. I want to store, instead of, right now I'm printing all these strings. Instead of printing them, I want to store them. But I don't know how many there are. What are my storage options in Java? Okay, so I can put it in an array. I can put it in a list. I can put it in a stack. Kind of talked about queues, but so let's say it's arrays versus linked list. Which should I use? A linked list. Why a linked list instead of an array? We don't know how many elements I have, right? I don't know how many elements I have. So a linked list will allow me to just add elements one at a time until I have it filled up, right? So have I shown you the built-in linked list type already?
No.
All right. So I'll show you built-in. So I'm going to say a linked list. We're going to have a type string. This is something called generics. We'll talk about that later. Just pretend like this is how it works right now. Actually, I'll just show it to you right now. Linked list LL is equal to a new linked list. That gives me a blank linked list. I need to import this from java.util, I think. Yeah. So I brought in java.util linked list. So this is already built into the language. Good.
What's the difference between the linked list and like an array list in Java?
The underlying implementation, array list, what it does is it grabs a certain amount of memory, so it's still done as an array. It just says, here's an array that's probably big enough. And as you load stuff into it, as soon as it becomes not big enough, it actually creates a new array, copies everything over, and expands it, but it just does it less often rather than on a per element. From a user perspective, if you're not worrying about the memory impact behind the scenes, you could probably say an array list is more memory inefficient, but probably faster than a linked list. Just because it's implementing itself, it's almost like a halvesy solution. The underlying data structure is an array. It's just saying we're going to try to be a little friendlier to memory than you would otherwise be, just adding one element at a time in perpetuity. Okay, so here's a linked list. I'm going to start putting stuff into that linked list. So instead of printing this stuff out, I'll say ll.add, and I'm going to add whatever I read in from the next line. Okay. Then, after I've read all that stuff in, I'm going to go ahead and prove that I have everything read in from that. So I'll create a for loop. Int I is equal to 0. I is less than ll dot, what is it, count? Size? Yeah, ll dot size. That's the number of elements in the built-in linked list type. This is equivalent to an array's length. Okay, this is the number of things in the linked list. I++, and each time through I'll say system.out.println. Okay, now pay attention to this part here. So I'm going to say ll.get. Can I make this any bigger? Is this just as big as it can get? Can we read this okay? If you can't, just gather up here in a pile. All right. So here's the get method, and it's asking me for the index. All right. But notice the kind of value it returns. It returns an object. So the default linked list knows how to hold generic objects. So that means when I say give me the element at bucket I, it's going to come out as an object. Now, because it happens to be a string, this would actually work as is, but we're going to pretend like it wouldn't have, because if it was any other object, I would have to cast it to a string, because it came out as this generic object that I know is a string, because I know when I put it in there, I put a string in there. It just got generically stored because strings are objects. So this linked list allows us to store anything that is an object type. So if I put it in and it generically stores it as anything that's an object type, it just kind of has, big enough containers in there that can hold anything that's an object. Instead of very customized, you go to a store and they sell like paper clips. They just put them all in shoe boxes. Your big waste of space, but paper clips fit in a shoebox. Right? So it's kind of that type of thing. I have this collection of generic containers that can hold anything that's an object. I know I threw a string in there. I know I threw a paper clip in that shoebox. So when I open up that shoebox and I reach in blindfolded, I'm pulling out something. I know it's a paper clip. But if I want to start using that paper clip programmatically, I have to convert it back to a paper clip. I need to let Java know this dude's not an object. He's actually a paper clip. Make sense? So he will come out as a generic object. I will then say, by the way, he's a string. Trust me. That's me casting him to a string. So this is going to be us testing that linked list. So up here, what am I doing? I'm reading from the file into the linked list. Then here, I'm just going to go through my linked list, proving it's filled up with that stuff. All right? So we'll go ahead and hit play there, and I get all my stuff. What's up?
So then, when it prints out an object, so what does it gonna be if you don't put the string in there?
Well, okay. What it's actually, if I don't say this, what it's actually going to do is it's going to print out that guy. The 2-string version of whatever you passed in there. And remember, objects have a 2-string. And that 2-string method prints the crazy looking memory address.
Oh.
So if we were to create and we'll do this in a little bit, but if I were to create a linked list of objects, I would put stuff in there like basketball players, like we did earlier this semester, where maybe we did not implement the 2-string for a basketball player, it would revert to the object's 2-string, which would give me a memory address. Because we're storing strings here, strings actually do have their own version of 2-string, which shows the nice looking string. So the reality is if I don't put string in front of this guy, it's going to look fine. Because they're strings. Because the thing I happened to store in there was a string, and strings do have their own version of 2-string. And their own version of 2-string, instead of showing memory addressy thing, shows a nice pretty string. So that's what's happening here. It's calling this guy's .2-string. You'll see it's the exact same output. Okay? But if we're playing the game here and saying, this guy's coming out as a generic string or a generic object, I know he's a string, so I'm going to convert him to a string, I can do this. This would be kind of the old school way of working with generic linked lists, where you can, either it's built into the language or you had to write your own linked list, but you kind of wanted to write linked lists one time and have them work for all sorts of different objects. You build that utility once instead of having to write specialized linked lists for every little type you want to store. You would write a linked list one time capable of holding objects. The payload would be an object. Then you could put anything that's an object in there, but when it came out, you'd have to cast it back to what it actually was. Okay? So this is what we would have had to do a long time ago. Java, and C# has this, has introduced something called generics. So we have a little syntax that looks like this inside angle brackets. Now, when I say ll.get, look at the type that it returns now. He returns a string now, because I created this linked list specifically for holding strings. So now you solve both problems. You're able to write it generically to work for anything's an object, with the caveat that you can, at the time of creating it, you can let them know the kinds of objects you're going to have in there, and it'll go and update all the return types to the kind of object that it's actually coming out to save you from having to typecast it. That type of thing. So it's a convenience. It's not solving all the world's problems. It just makes our lives a little bit easier. That makes sense? So in this case, I'm storing a bunch of strings, so I can just create a linked list of strings, even though since it's a string, it didn't matter in this case because it comes out as an object which has a toString, which has exactly what we want. And life goes on. But we'll use it as strings here, and when we get at a certain element, we'll see this guy still works. All right, so there's all of our Bible books. All right, inside of a linked list. Now, we probably like to, especially if we're going to do merge sort on these, we'd probably like to put these into an array. But before we do that, we probably want to take our Bible books and turn them into objects. So maybe a Bible book, maybe we have a book object, and then we add book objects to a Bible object, because a Bible object is a collection of books.
Okay.
Right? Let's keep Bible in the front. We'll say Bible book, and we'll say Bible object. Keep the Christian worldview flowing, right? All right, so, and what we're doing is we're creating objects relative to the real world, right? If you grab a book off a shelf, inside that book, well, the book has what? It has a title, okay? And inside it has a bunch of chapters, and then you might store other things associated with it, but we're just going to store those two things right now. Yeah, you have page numbers, you might have a specifically an index where you can jump to places, whatever it is, it has a word count, all sorts of stuff, right? We're going to store two pieces of information just to keep this simple. So I'm going to create a new object. So we're practicing stuff we've been doing all semester, right? I want to store, I have the string format of some information where I have a title and I have a number of chapters. And I want to go ahead and suck that information into an object called Bible book, where I can piece out the title and I can piece out the number of chapters and have those two pieces of information as usable things inside of an object. All right, so I'm going to create a new class, and we're going to call this guy Bible book. Okay, we've decided that we're going to keep track of two pieces of information for our Bible books. We're going to keep track of a title, and we're going to keep track of a number of chapters. So we have a private string title. We have a private int number of chapters. Okay, what are these guys called? Fields. These are the fields of our object, right? All right, now we're going to write a constructor. So public Bible book, and this guy's going to take a, let's call this guy a source string, because right now all our Bible books are stored as source strings. Okay, now this is a little different than, I think we've probably done something like this before, but typically what we're used to is we're used to saying, okay, well, I'm going to have a constructor here that's going to take in a string title, and it's going to take in an int number of chapters, and then inside here I'm going to say this dot title is equal to title, and this dot number of chapters is equal to number of chapters, and that's what our constructors typically look like, right? But I happen to have my the information related to my Bible book currently stored in this string, right? String that looks like this guy. So if I pass this entire string in, I can then use that guy to split this up and get the title and get the number of chapters. The job of a constructor is to initialize an object. While we maybe often pass in the two pieces of information because we already have them for an object, in this case, my information is effectively encoded in a string, and I need to parse it out. So I'm going to pass the constructor the string, and I'm going to have him go through this guy and grab the individual pieces. Okay, so what I'm initially going to do is I'm going to split on the open parenthesis. So I look at the pattern here, I look through all of my strings here, and we have the title followed by a space. We'll clean up the space in a second with a trim. Always followed by an opening parenthesis, right? So I can get my two pieces real quick just that way. So I'll come in here. We'll revert back to my source string version of this. We can actually have two constructors. If I happen to have my title and my number of chapters, I can just build a Bible book directly like this. No problem. We can leave that constructor in there. If I'm ever in a case where I do already have that piece of information, I can create my Bible book that way. All right. But I'm going to have a public Bible book, and this guy's going to take a string, source string. Now tell me, are these different constructors? Actually, that would be. Notice this has an error right now. Even though I've named these variables different things, this is a constructor that takes a string and an int. This is also a constructor that takes a string and an int. Java is not going to be able to tell the difference between those two. Okay? So you cannot have two constructors or two methods that take the same type of parameters. Number and type of parameters. Variable names do not matter. Okay, but this guy up here is just going to take in a source string. All right? It's going to take something that looks like this guy, and then I'm going to go through the process of parsing him out. So we're going to go ahead and we're going to say string array parts. How do I split a string up? If I have a string like this, what tools do you have in your toolbox that allows us to take this string and break it into pieces? That's the problem you're trying to solve. Do we have any automated tools, or could we write something that goes through and does that? Okay, we have split. What if we didn't remember split? Okay, how would we use char at?
I was just saying, I'm not sure how to use it. I probably use this white space.
Do we have like if chart at the position something, but if there's like a parenthesis, then
We could do that. We could say get title. So we could do something like this. We could say this dot title is equal to the empty string. And then we could say for int I is equal to 0. I is less than source string dot length I plus plus. And then walk through and say if source string dot char at I, if the current character I'm looking at is not equal to a parenthesis, an open parenthesis, if it's not one of those guys, I'll go ahead and keep it. I'll say this dot title plus equals source string dot char at I. Just tack it onto it. As soon as I do hit the opening parenthesis, well, I can say I can break out. Otherwise, I can start working on another string, right? So maybe I could, instead of always building title, I can say string cur string is equal to the empty string What I'm actually building up here is let's just do it for the first part. This isn't going to be the way we do it anyways. We can make it work this way. We just have to have like a flag to let us know that we already found the title. Let's do it. It'll be fun. All right, so we're going to be building up curString here. So we start off with this empty string, and I'm just, until I hit an opening parenthesis, I'm working on curString, right? As soon as I hit an opening parenthesis, that means that I now am going to be working on something else, right? So I'm going to keep track of a Boolean here called found title. We'll have this guy set as false. So while source string.char at I is not equal to an opening parenthesis, and before that I'll go ahead and while found title, so while not found title. So as long as I have not found my title yet, and I'm not looking at an opening parenthesis, I'm going to be building up my title. Okay? And actually doing it this way, I could then choose to use this .title here instead of curString because I'm doing it all in one. I was going to do curString if I was going to break it into two different things. Now I'm going to call this guy chapter string because I'm going to be building up my number for my chapter. All right. So if I have not found the title yet and I'm not looking at an opening parenthesis, collect characters. These are my title, the part of my title. As soon as I find an opening parenthesis, so else if, actually I think it'll look, it's going to be the same logic, but I think it'll look cleaner doing it this way. I'm going to say, if I have not found my title, if I'm not looking at a opening parenthesis, then collect characters.
Hang on, when you say not found the title, does that mean?
This is equivalent to
true.
saying equals false. If found title equals false. I started found title off as false because I have not found my title yet. I'm still working on collecting my title. So found title, if found title is currently equal to false, the shorthand way of saying that is not found title.
So for example, if you say found title is so true, so then you put not found title, would that be true too?
Well, not flips a Boolean. So not true is false, not false is true. Remember, an if statement, always goes forward if this value boils down to true. That's when an if statement moves forward. That's when we get into that if statement, right? If whatever this value is, whatever it is, no matter what it looks like, because it's a Boolean expression. Boolean expressions boil down to a single value of true or false. So if whatever that expression is boils down to true, we'll get into that if statement. If it boils down to false, we won't. So I can write it as found title equal to false, like that. Right now, I started off found title as false. Is it true that false is equal to false? Is that true?
Yes.
Yes. Is it also true that the opposite of found title is true? Not false is true. Does that make sense? So this would be probably the more programmatic correct way of saying this. But if you're uncomfortable with the whole not symbol thing, you can say found title equals to false. It's not going to hurt anything. All that you're doing here is ultimately this is going to become false. And every day of the week, false is equal to false. That's like saying 5 is equal to 5. 7 is equal to 7. Make sense? All right, so choose your poison. We'll leave it like that. It's probably easier to read this way. And who cares if we're putting a little extra burden on Java? It's its problem. All right, so as long as we have not found our title, that means we're working on our title. That means we're still looking for that opening parenthesis. And as long as what we're currently working on is not that opening parenthesis, we're going to collect things. All right? Now, as soon as we do run into that opening parenthesis, we know actually that we're done collecting our title. So we'll say found title is equal to true. I found it. And what will that mean? It means we will never get inside this if statement again. Already found my title. He's already built up instead of this dot title. I technically will have an extra little space there. So if I want to clean that space up, I can just come in here and say this dot title is equal to this dot title dot trim. That'll take any extra spaces off either end of it. And that just cleans it up a little bit. No harm, no foul. All right. But then I mark my title as being found, so I'm done with that search. So now each time through this loop, as I continue to walk through that string, I'm no longer looking for titles. Now I'm looking for numbers, right? So now I'm going to be in my else thing. So if I'm here, I'm looking for number of chapters. That guy? So I just hit this. And now I'm on my next bucket of I, which is this guy. Now I look at all of these options here, and there's no spaces before it. So the very next character is well, I'm going to be collecting numbers until I hit a space. So I'm almost asking the same question as I had before. If source string dot char at I is not equal to a space. If I haven't run into a space yet, which indicates the end of my number. This is when I'm done reading in numbers right there, right? So if I haven't bumped into a space yet, I'm going to collect my chapter string. So I'll say chapter string plus equals source string dot char at I. Make sense? Now, as soon as, go ahead.
When you're running into the parenthesis one, but then when you pass it into else, it's you're still at the position of the parenthesis one. It's not, you're not moving.
No, I'm past it. Because when I finally hit that parenthesis, when I hit that parenthesis, I got into this if statement. All right? Because I had not found my title yet. My title was still false. As I'm walking through here, okay, have I found my title? No. Have I found my title? No. Have I found my title? No. Have I found my title? Not yet. I'll get into that version of the if statement. Then I notice I am looking at a parenthesis. So I have not found my title yet. I'll jump inside here. I say, am I looking at something other than a parenthesis? I'm not. I'm looking at a parenthesis. What do I do if I'm looking at a parenthesis? I drop down to the else. I finalize my title. And then I flip found title to true. So then the next time through the loop, I won't get into this else here because I already got into this if. So the next time through this loop, I will be one greater. So I'll be sitting right here. And I'll immediately skip this if because found title is currently equal to true. I'm not looking for titles anymore. So I'll drop to this else and I'll ask the question, am I looking at a space? If I'm not looking at a space, collect, not a space, collect it, not a space, collect it. It's a space, I finished collecting my number, let's convert it to an int, set my guy up top, bust out of this loop, I got everything I need. Because all this other stuff afterwards is fluff, right? So if I'm here, I'll go ahead and I'm going to say this dot number of chapters is equal to, how do I convert a string representation of a number into a numeric representation of a number? Integer.parseInt. Not cast, not cast. Not cast. I cannot do this. I can't say the int version of chapter string. Chapter string is a string. It's like a string like 43. I can't say, give me the int version of 43. Not in Java. Okay. Java requires me to parse the integer out of that, or write my own version of parseInt if I didn't remember. So this is integer.parseInt, and I'll pass it the string I had just been collecting. Now I have my number. I'll break out of my loop. So break breaks out of the closest loop, which is this guy right here. So now we're past the end of this guy. And I should be able, now I should have my collection of Bible books. Well, I should have a Bible book. Okay, we'll go ahead and we'll teach this guy how to display himself. So we'll say public void display. And maybe when we display a Bible book, have we done format strings before in here? Let me show you. This is kind of a convenient way, because otherwise we kind of glue together a string. We'd have like the book name. So I would say something like system.out.println, and then I can say something like I would say this dot title concatenated with maybe a dash, and then I concatenate that with let's do a dash number of chapters colon space, and then I concatenate that to number of chapters. So I'm kind of building a string to print there, right? So here's my title. I'll tag that on to the front of just this random text I decided to put in there, and then I'll tag on number of chapters that I read in, proving I got the two pieces of information. All right, so let's just test it like this, and I'll show you the format string thing. So we'll go back here to driver. So now, instead of going through all of my linked list and printing them out, what I'm going to go ahead and do is I'm going to create a Bible book. So actually, let's do this. I'm going to say, actually, I don't want to have the array yet, because I'll put that inside of my Bible object. So in here, I'll just create a Bible book. Bible book BB is equal to a new Bible book, and my Bible book expects me to pass him a string, right? That's the string I want him to parse. Then I'll go ahead and say bb.display. So if this all works, bb.display should show my now formatted Bible book, which is proof that I've got my two pieces and then displayed them by putting them back together. So there's my Bible books. My formatting was a little bit funky. I put an extra parenthesis there where I probably wanted to have it after my thing, but just roll with it. That's all just a poorly formatted display method. Completely human error there. All right. But I got all my pieces, it looks like. No harm, no foul. Okay. So let me show you the format string thing here. Let me steal.
Was it like the percent thing?
Yeah. I think there's a thing I can do it with system.out. Yeah. System.out, that format. So I can go ahead and say %s number of chapters, and we'll make this guy look a little better. And so before that thing here, we'll say %d for a decimal value. And then I'll say this dot title and this dot number of chapters. All right. So, and if I wanted to kick it down to the next line at the end, I'll need to put my carriage return in there, because I'm not working with a println now. I'm working with this format thing. Go ahead and run this, and there's my prettier looking output now since I moved the parenthesis to the right place. Okay. So now I'll go ahead and I'll create a, actually for the sake of time, I'm not going to create a Bible object because I want to get merge sort done for this guy before class is over. So what I'm going to go ahead and do here is I'm going to, up here, I'm going to create an array of Bible books. So I'm going to create a Bible book array called the Bible. All right. I'm not going to give him a value yet because at this point, I don't know how many books I'm going to be putting in there. But I can go ahead and give him his value between these two loops. Because after this while loop, LL has all my things in it. So LL.size is the number of buckets I want to have in my array. So I'll say the Bible is equal to a new Bible book array of LL.size. So I'll create an array of the equivalent to the size of my Bible books. There's actually probably a, do I have like a 2 array? Yeah, I do. I can just convert that guy to an array. But that's less fun. We don't know about that tool yet. Okay, so I'll create an array capable of holding all the elements of my linked list. I'll go through my linked list, and each time through, I'll say the Bible at bucket I is equal to this brand new Bible book that I'll build using that linked list. So I'll grab my current format string. I'll pass it to the constructor of my Bible book, which will create me a Bible book, and I'll store that Bible book at bucket I of the Bible. Cool? All right. So now I want to call merge sort on my array of Bible books. This is not an array of integers now. And let's say I want to sort this guy on from smallest to largest of chapters. Okay, know what I'm talking about? So what I'm going to do is I'm going to jump back over to Android Studio. And we're just going to grab our implementation of merge sort and we'll modify it to work for, instead of ints, it's going to work for Bible books. It's not our project. All right, so here's our, where did I write my merge sort? Up higher? Here, so I'll just grab those methods there. That's my merge sort for ints. I'm going to bring this guy into Eclipse. And I'll go ahead and I'll write it down here below main. All right. And I'm going to make these guys all static since they belong to the class. Okay. Now, this guy is no longer taking in a, so my merge sort's no longer taking in an integer array. It's now taking in a Bible book array. Right? All right. And it's also no longer an instance method. So I'll just have it call, this is driver.mergeSortHelper. Okay. And driver.mergeSortHelper, I'm going to have that taken a Bible book array, so that's why he's upset right now. So I'll go down to merge sort helper. This guy's not taking an int array, he's taking in a Bible book array. Okay, so this guy's happy again. When we do merge, merge is taking in a Bible book array. Int begin, int end. Temp is going to be a Bible book array. as we go through all of, and this is a Bible book array, as we go through all of our elements in temp.length, deciding which guy wins, I'm not comparing. So this if statement says, are my positions legal? But this is where I say, is the value at these positions less than the other guy? I'm not comparing one Bible book being less than another Bible book, because this guy right here, this is a Bible book, correct? I want to know about that Bible book's chapter count. So I need to go into my Bible book. I'm going to generate. I thought it was source. Yeah, here's generate getters and setters. I'll go ahead and give myself a getter for number of chapters and a getter for title because I want the title later. Just generate that. So now I have those two guys. So back here inside of here, this is a Bible book. This is a Bible book. Deciding which one comes first in my sort here depends on who has less chapters, who has fewer chapters. So I'm going to say this guy dot get number of chapters. Less than this guy get number of chapters. That make sense? I haven't changed my logic at all. Merge sort is merge sort. I'm just changing what I'm comparing. Otherwise, so if he's the winner, declare him the winner. Otherwise, he's the winner. He's the winner. He's the winner. That's all I had to change there inside of merge. The one place where I actually pit the two guys against each other. I changed what I was comparing. Then I copy the crap back over. Merge sort helper takes in my Bible book array. Begin and end work the same way as they worked before. This is no longer called merge. It's no longer an instance method. Now it's a class method. There's my driver.merge. So that's merge sort for my Bible books. So what I'll go ahead and do here, I'm going to write a little method to display my array of Bible books. So public void display Bible books. This guy will take in a Bible book array. We'll name it AR. This guy will say for int I is equal to 0, I is less than AR.length, I plus plus. And we'll say AR at bucket I dot display, because that guy's a Bible book. So I'll tell him to go ahead and display himself. All right, so then what we'll do right after, so here I am filling my Bible array up. I'll go ahead and display that guy. So I'll say driver dot, what do I call it? Display, oh, I made this guy needs to be static if I want it to be owned by driver. So driver dot display Bible book array. I'll pass it my Bible book array called the Bible. Then I'll go ahead and say driver dot merge sort. I'm going to pass it that Bible book array, the Bible. And I'll go ahead and put a little system.out.println and maybe put some asterisk there to divide before and after sorting. So after I've sorted it, I'll go ahead and display it again. So read from a file, filled up a linked list because I didn't know how many there would be, created an array of the appropriate size, filled the array with the contents of the linked list, displayed all my Bible books, called merge sort of my Bible books, gave myself a little visual separator, displayed it again, which should have them displayed from smallest number of chapters to largest number of chapters. So here's the original Genesis. This is Bible order. Here's my divider. And then here's smallest chapter, Obadiah. That one's a quick read. All the way up to longest chapter, which is Psalms. What do you think? Lots of good stuff today, right?
Mhm.
Get crap that we need into a program from an external source. Merge sort on different data types, which we saw we had to change like 2 lines. Oh, actually, we had to change 1 line and then the type of array we were passing around. Go ahead.
What kind of other like information can you bring into Java?
Anything.
Or is it like different? Like is
It
the
only works for Bible stuff.
what? No.
Yeah, this is Concordia, pal.
Is it like different like per type of file? Like you have to like change.
Well, you could bring in any kind of file you want, but if it's going to be like a binary file, like a .exe or something, I mean, you're going to have to know how to interpret it.
Right.
So, for instance, like PDFs are a big deal. Like you probably have some cell phone app or something like that where you can like share some file with somebody and it creates a PDF. So PDF is a known file format. It's kind of like JSON or kind of like CSV, but it's like a known file format where you can generate that kind of file. So if you read in a PDF, you wouldn't be able to deal with it as plain text. We're dealing with stuff as plain text right now, which makes it nice and simple. We would have to probably either write our own or use a third-party plugin that allows us to kind of read line by line PDF content, which would come in some sort of formatted type way, kind of like an XML document or something like that, where we might have to pull out the actual data because there's going to be a lot of formatting tags around it for things being in bold and pictures being formatted, right justified, and that kind of stuff. But, I mean, any data is fair game. You just have to then have the tool to work with the data. Okay? And we really wrote this code here today, very, I don't know, you might say ghetto version-y, because, I mean, we could have made this constructor for Bible book way shorter. We just basically said, look, I don't know about any way of splitting up a string with any built-in tools. So we just did it ourselves. And it wasn't that bad, right? We had to come up with a little algorithm. This is equivalent to like a 250, write a method that does something, right? It's a little bit, you have to think through it, but it wasn't hard. Right? So, there. An actual real solution to a real problem. Now you know the order to read the Bible in, because you're probably going to give up halfway through. So now you have the shortest path to get to the halfway point. is what I'm saying. All right, questions about any of that? Okay, remember Bible or Bible study? Yeah, go to Bible study today. Find a Bible study and go to it today. You're going to need it for this hackathon. All right, hackathon 8 a.m. In this area on Saturday. Don't be late. It goes till 8 p.m. If you're not in contact with your team, a couple of you in here are team leads, so shame on you. You should be are you in contact with your team?
I've sent out stuff to everybody.
Have they all replied?
No.
Okay, send it out again every 5 minutes until everybody replies.
Gotcha. So it's gonna
I'm
hit
gonna
an email.
hit you until you respond.
Okay, so start talking about, if you saw what I put up for like what the project's going to be, there's going to be a little utility in there. Could be a dice roller, could be you can take the wimpy route and just pick one of the ones I gave you, or as a team come up with something interesting. Make a little game, but don't make it so complex that you're not going to be able to do the other part. I want the focus to be on registration screen, login, authentication with Firebase, and then some kind of profile management, because that's something pretty much every application you ever write will have. Right? And then have a little screen for something fun. All right? Try to divide your teams up into little subgroups, maybe 2 or 3 little pods to work on stuff. Maybe identify the couple of people in your group that have had Android Studio background. Remember, anybody who's in your group that's from 200 has had Python stuff but has never seen Android Studio. All right? So you're going to have to help them learn that just like somebody helped you learn whatever you were learning when you were a 200 student. All right, I will see everybody on Saturday. And I will be sitting in here on the big screen TV watching the Masters.